You can solve 9 out of 10 array problems with 2 pointers and a hash map. But graphs? A whole new mindset. Today, we fix that. BFS and DFS. The only 2 graph algorithms you actually need. A graph is just dots, connected by lines. Cities, linked by roads. Friends, on a social network. Web pages, linked together. Once you see it, graphs really are everywhere. In code, we usually store a graph as a list of neighbors. For each node, we keep a list of the other nodes it connects to. Quick to build, quick to scan. Almost every graph problem comes down to one of 2 questions. Can I reach this node from where I am? Or, what is the shortest path between 2 nodes? 2 questions, 2 algorithms. Depth-first search is how you would walk through a maze. You pick a path, you follow it as far as it goes. And when you hit a dead end, you back up and you try another. Simple idea, powerful tool. Start at any node, mark it visited so you don't loop forever. Now jump to a neighbor you haven't seen yet. Repeat, go deeper, mark, jump. When there's nowhere new to go, back up to the previous node and try a different branch. Here is depth first in JavaScript. A visited set, a recursive helper, and a loop over each neighbor. The recursion, going deep, is the search descending. The return is the backup step. You can write the same algorithm without recursion. Just use a stack, push the start node, then keep popping and pushing neighbors until the stack is empty. Same result, no call stack risk on huge graphs. Reach for depth first when you need to find any path, or detect a cycle, or count connected pieces, or order tasks with dependencies. Depth first loves recursion-shaped problems. Time complexity? Big O of V plus E, you touch every node and every edge once. Space? Big O of V, for the visited set and the call stack. Now, for breadth first search. Picture dropping a stone in a pond. The ripples spread out evenly. Close points first, then farther ones. That, in one image, is breadth first. Start at the source. Mark it visited. Visit every direct neighbor first. That is distance 1. Then every neighbor of those neighbors, distance 2. You keep expanding outward, one full layer at a time. In JavaScript, a queue is just an array with shift and push. Add the start node, then in a loop, take from the front. Mark each unseen neighbor, and push them to the back. Always front to back. That is what makes the ripples work. Breadth first is the algorithm for shortest path in an unweighted graph. Also great for level order traversal, finding the nearest match, or solving word ladder style puzzles. Same complexity story. Time? Big O of V plus E space? Big O of V, for the visited set and the queue. Time for the side-by-side. Depth first uses a stack, explicit or recursive. Breadth first uses a queue. Depth first finds any path. Breadth first finds the shortest. Same time complexity. Different shapes. Different jobs. So, how do you actually pick? See the word shortest in the problem? Reach for breadth first. See the words any or all. Reach for depth first. Counting connected pieces? Either one works. Depth first is usually shorter to write. 3 bugs you will hit the first few times. 1. Forgetting the visited set. You loop forever. 2. Using a stack when you needed a queue. Wrong shortest path. 3. Marking visited too late. You process the same node twice. Quick recap. Graph problems are reach problems or shortest path problems. Depth first goes deep with a stack. Breadth first spreads out with a queue. Pick by the question. Up next, we will apply this to a real interview problem on CodeBrainery. Subscribe if this clicked for you. See you in the next one.